Morning, everyone. May buntag. Yes, so by the way, this meeting, we're going to discuss some items under one-dimensional bars. No, so I think we have not discussed this subtopics no under one-dimensional bars in our last meeting. Mali mapil na to, no? So I think we also have problems in our assignments nga naani nga mga items we need to discuss this. So we'll just tola ni siyang tiwason, no? So one-dimensional bar. So next week, next meeting, ang atong topic would be about two-dimensional trusses. No? So to give you a recap, no? So last week, especially those who were not able to participate no in our meeting. So ato ni siyang i-discuss kaning analysis of one-dimensional bars. Okay, so this is one of the sample problems no nga atong i-discuss. So kani siya tulo ni siya ka members na there are how many nodes? 4 nodes. Now if you recall, mingon ka og one-dimensional bar, ang usa ka node 1 degree of freedom na siya, meaning usa ra man na siya ka translation on the principal axis. So since there are 4 nodes for this entire structure, okay, this system, so that makes our stiffness matrix no for the entire system to be 4 by 4. Okay, so expect 4 by 4 na stiffness matrix. So ang buhaton nato is ato i-set up ang stiffness matrix per element ato siyang i-combine to form the system stiffness matrix or structure stiffness matrix. So in this case, we expect it to be 4 by 4. So mao ni atong gibuhat, no? So kada member mao ni ang iyang mga stiffness matrix. After that, ato siyang i-combine. Ang expectation na ginato is 4 by 4 siya, no? Now ang pag-combine, so mo gamit atong mga markers na to, di ba, no? Okay, so mao na ni ang result sa pag-combine na to. Then after that, we have to form the force displacement relationship. So this is your F, this is your K, this is your U. Once you have this, imo na tong i-apply ang boundary conditions. So by simply eliminating the rows and columns that corresponds to 0 displacements, no? So in this case, 0 man siya, first row kana, first column. Yeah, fourth row kani, fourth column. So ang mabilin karon kanina lang kani og kani, mo na gitawag nato og reduced na sadya, no? Mo na ang reduced structural stiffness equation. Okay, so from here, if you notice, you only have the displacements as the unknowns. So from here, you solve the displacement. So it's either you get the inverse of this, no? Okay, you multiply that with the force matrix to get the displacement matrix. So once you have the displacement matrix, then you can solve now the reactions by simply substituting it here, no? Substituting mo sa overall force displacement equation, no? So this one. So masolve na sa ninimo ang imong mga reactions. So these are the reactions. After that, it's easy to solve the member forces. One is you can go back to the force displacement relationship per element. So katong ganiya. Or you can draw the free body diagram also, no? So to solve the member forces. So it's actually pretty straightforward. So akong balikon, so imong buhaton is you have to set up the stiffness combine. Okay, once you combine, then you have to eliminate the rows and columns that corresponds to 0 displacements, meaning you have to apply the boundary conditions. Once you have the reduced equation, you solve the displacements. After you have the displacements, you solve the reactions. Then after the actions, you solve the member forces. As simple as that. No? That is how to analyze structures using matrices. No? So the same principle would apply to other types of structures. No? So from to the dimensional trusses up to three-dimensional frames. Maura gyud na siya. No? The only difference here, again, I emphasize this no over and over again. The only difference is mag-anam og dagko ang imong structures, mag-anam pod og kadaghan ang imong magkadako pod ang imong mga matrix. No? Okay, so basically that's the only difference. The principle, maura gyud na siya. Now, how about if we have non-zero displacement? So, for example, we have this problem. So, we have this structure composed of two bars. Okay, so this is element 1. This is your element 2, no? So, from node 2 to node 3. So gihatag na ning iyang stiffness karon. So in case wala na siya gihatag, you need the area, the modulus of elasticity and the length, no? So mao man karon ang atong stiffness, di ba? For one-dimensional bars. So karon in this case gihatag na siya tanan. No? Now kani siya is fixed yan, no? So meaning ang movement ani niya U1 is 0. Kaning U2 na kay movement, no? So U1 is 0. You have U2, right? No? Move ba niya siya? And of course, obviously, you have also U3. But in this case, ang U3 is given, gihatag sa diyan, no? So meaning, ang displacement sa usa ka node is given. So non-zero siya. No? Okay? So if you set up the matrix equation, yung nani siya, no? Ang you have to expect nga 3 by. So in this case, 0 ang atong U1, ang U2 nato is unknown, ang U3 nato is given siya. So ibutang lang nimo diha. It is negative because it is going to the left. Okay, so as simple as that. No? So that is if you encounter a problem where the one of the displacements is known. Okay. Now let's go to non-nodal forces. So far what we have plus aning forces. How about if ang atong force karon wala sa node gi apply? Okay, so gitawag na siya non-nodal forces. Now one approach to solve this problem is you add several more nodal points. So magbutang ka, for example, mao ni karon ang imong load. Magbutang ko dire og mga nodes. So that's one, no? Okay. So, pwede sad ako na siya tagsa-tagsaon ana daghanon gid ako maayo, no? One, the concentrated load so that the load will be acting at a nodal point, and several more on the region of this distributed load. So that's why I put additional nodes here because this is a distributed load. So, okay. Now, the problem here is we have added nodes. We also added a number of functions here. So may tabo that you will be dealing with large matrices na, no? Which is it will not help, no? Okay. So, but anyway, that's one of the solutions. Okay, tignan niyo ang screen. Hello? Can you see the screen?
Yes.
Okay. Now, ay mas systematic, no, pag-approach or pag solve aning mga non-nodal forces. No? So one option here is to use this equivalent nodal forces. Now, which act exactly opposite the fixed end forces. So, kaning equivalent nodal force na to equal siya sa fixed end forces. The difference here is this one acts opposite, okay, in direction to this fixed end forces. So, it should be negative. So, I would like you to refer to this diagram. Is known as the superposition diagram. Suppose we have this element, okay? So, mao ni karon ang akong non-nodal force, okay? So, that's the direction of the force here. So, obviously, we have a reaction here, no? So, assuming this is fixed end. So, ang fixed end forces ana niya is kani equivalent niya, no? Okay? So, plus the equivalent nodal force na to, no? So, equivalent nodal force na to, this one. No? So, kung imo na siyang i-add, i-superimpose nimo, ang result na would still be the same, no? As the original structure na to. Okay. Now, if we put this in the equation form, no? So, this is now the total force in matrix form. So, it should be F plus the F equivalent, which is equal to K U. So, that's so if you want the true nodal forces, so you simply add this fixed end forces. So, kani siya plus the fixed end forces. Mao na ni karon, no? Okay, so because the equivalent force is simply equal to negative of the fixed end forces. So I believe some of you are quite baffled with this. Let's go to an example. So now in this problem, we are required to determine the fixed end forces for this bar element with uniformly distributed load as shown. Okay. So ipangita is fixed, just the fixed end forces. So we need the fixed end forces, no? So kay ang equivalent nato nga force is simply equal to the fixed end force naman na siya. Only that it is opposite in direction. So for example, kani nakuha ni nga nanong load. So well, kani sayon ra kayo kay constant raman siya, no? Okay? So constant raman niya, uniformly distributed load siya, no? So ang imong intensity is simply equal to P sub O, which is a constant. The length is L. Well, obviously, kung ako na siyang to get the fixed end forces, mura na rin ako sa i-fix diri karon, mo na ni. Okay? So mo ni karon ang ako mga fixed end forces. Since this is a constant, so dili ra gini siya problema, no? Ditso ra pwede ra ka moingon nga you have to expect no kaning R1 is equal to R2. This is simply equal to P sub O. No? I multiply that by the length. Divide this by 2, di ba? Because the total force here is simply PO constant times the length, di ba? Divide it by 2, so that would be your R1, which is equal to R2. Okay? So from the equilibrium here, so R1 plus R2 is equal to POL, di ba? R1 plus R2 is equal to the same, so that's why R1 is equal to POL over 2. No? Pero nga to, solve na siya using assuming ba nga base niya og dili ni siya constant, so how are you going to approach that? No? Kani siya, you can easily check this because this is a constant. No? So drawing a free body diagram of a portion of the element, so assuming you pass here a section. So let's try to draw the free body diagram. So kani, no? The distance assuming is x, no? From this reference point. So ang imo karong force dire would be P time PO times X, no? So, ang total force nimo is PO times X. Okay? So, ang imong fixed end force diri karon is the force here is P as a function of X, no? So, this one as a function of X would be R1 minus kani siya is PO times X na length. Okay? It should be the force at this imaginary section. So note that the total elongation of the element is 0. Why? Because it is fixed. Di ba? So applying this relationship, so katong delta, di ba, equal to PL over E, no? So ang total na to karon, sum ni nako karon, so you have to do integration, no? So from 0 to L na to, sa total length niya, that should be 0, and the total displacement here is equal to 0. So if we apply this one, mao na yung mahitabo, no? So 0 siya. So this one is the force, then dx E. So this one is constant. I can place this outside. And what is this? The force, which is a function of x, R1 minus P sub OX, no? So the one I discussed earlier, no? Okay. So you have to integrate this one. So mahimo ning 1 over AE. So result na is R1x minus P sub O x squared over 2. No? And you evaluate this from 0 to L. So may tabo karon is when x is 0, 0 ra siya. So when x is L, mo na yung result. R1L, PUL squared over 2. No? So of course, this one, you put this here, becomes 0, 0. So what happens is your R1 becomes POL over 2. And R2 is also POL over 2. So as expected, no? Because this is just a kanang uniformly distributed load. Okay? So based sa inyong example, so dili lang ni siya atong ibutang kuan kanang uniformly distributed load, but it could be maybe triangular or parabolic, no? Or even elliptical load, no? Para mas challenging sa GR. I think you have this already in your integral calculus. Okay, obviously, no? Or differential equations. So, mao ni. So, mao ni ang atong fixed end forces. R1, R2. Equivalent nodal force na to, which is kuan lang siya, opposite ani niya. Ako lang ni siyang ibalhin lang nako, di ba? Kay kani mao man ang akong law, di ba? This one. So, para ma-consider nako siya as nodal force dire, I have to get the equivalent nodal force. But before that, I have to get the fixed end forces, which is kani. Di ba? So, ang equivalent nodal force nako, so opposite ra siya. Mura na ko ako na siyang tantangon, kani mo ya akong ipuli, no? Okay, and I can already analyze this. Mao naman yung atong discuss, no, sa kuan kanang mga sample problems na to, di ba? Instead of having this, o kani mo akong ipuli. Okay? Morning akong mga fixed end forces. Then I can proceed with my analysis. No? So instead of doing this, I have to analyze with this equivalent nodal force. But before this, I have to get the fixed end forces. Okay? So that means ako rin siyang i-fix. Ako rin siyang solve. So kani very simple because this is again uniformly distributed. I have to expect nga PO times L, that's the total force here. You just divide it by 2. Okay? So it's quite a bit challenging kung ang load na ko, ingunana na po, di ba? No? Or parabolic. Okay? Parabolic, ingunana, no? Or elliptical. No? So that would be little bit challenging. Okay, so these are your assignments. So I think ako na siyang gihatag last week. But ang deadline would be next week. So next week, we're going to discuss analysis of two-dimensional bars. Any questions or clarifications?
Pwede mo clarify, sir.
Ah? Yes.
Ikaw,
Lanil.
Sige po. Sure, sige. Sir, pwede mo clarify, sir, sa assignment, sir, kaning 1.1.3. Kaning third question man good, sir, kay sa 1.1 sa assignment kay niya na siya nga use the partitioning method and the method of removing rows and columns to solve. Pwede ra, sir, instead of the partitioning method kay mo gamit rami sa imuhang solution sa PowerPoint.
Ay, pwede ra. May problema. No problem. No problem.
So amo lang ni disregard ang kaning
Yeah,
instruction
okay
na
ra.
first
Yes.
partitioning method.
Yes. No problem.
And also, sir, just to clarify, sir, ang sa imong example, sir, and also there is a assignment, sir, kay naay unit nga K per IN. Does that mean K per inch pa, sir?
Yes. Ang problem lang nato is we are using here sa atong textbook we are using the English units, no? So dili siya SI units, so that means we will be dealing with pounds, inches, no? So mayroon ka keep, that's kung ano siya, kilo pounds, okay, per inch.
No. Okay, sir.
Okay.
Good, sir. And last,
at least kuan lang sad, no, kanang dili lang totally kuan bitaw kanang SI units lang sad ta, at least na lang gyapon tay you will still be familiar with mga English units gyapon kay the industry na lang gyapon na siya, no. May kaning mga strength sa concrete, so PSI lang gyapon ang gamiton. So 3,000 PSI kaning mga grade sa kabilya, grade 40, grade 60, no? Okay. So kuha na siya, that's in SI units na siya.
sige, sir. And last, sir, for me, kay pwede mo clarify, sir, sa 1.5, sir, kay naay kaning figure o sa ka-figure, sir, kay dili maklaro ang arrow, sir, sa 1.5 kaning unang figure, sir.
Akong ginaon ha.
Sige, sir.
1.5.
1.5, sir, na ang kanang figure P1-5A, kanang first figure, sir, kanang letter F kay ang iyang
1.5. Oh yeah, kaning mga 1.5 unsa man siya, mga kuan man siya, mga nonodal forces, right? Na?
Yes, sir, na dili maklaro ang F.
F, yes. Unsa may di maklaro ni ang
arrow sa F, sir. Mao ba kanang axial force ba na siya, sir, kanang naa sa sud sa
Oh yeah, going to the right ni tanan, no. Mo maning arrow niya going to the right, no?
ang sa F, sir, sad going to
Yes,
the right.
yes.
Sa sud.
By the way, dili ni siya beam ha, kuha na siya kanang bar naman ni siya. So ang iyang loads karon should be directed along the principal axis of the bar. Okay, so mo ni ang iyang mga direction sa load karon, kuha na gina siya. It's either going to the right or going to the left. But in this case, puro ni siya going to the right. Okay? Only nga ang iyang magnitude or intensity niya, for example, triangular siya, di ba? So nag-anam og kadako ang iyang kuan kanang iyang loads niya pag-abot na sa right. Did you get the point?
So to clarify, sir, ang example kaning second sir kay mo increasing na ang load ang
Hmm,
kaning ah,
yes, increasing siya, no?
so ang kaning sa kaning first figure sir kay bali mura ra siya kanang walay unsa ni sir kanang puros ra to the right sir like walay
Puro to the
increasing.
right lang, yes, puro to the right. Ang inong buhaton na ni exactly the same sa atong gibuhat karon, no? Ang ato lang karon sayon lang kayo because it is uniformly distributed. Then itabo sad karon is more or less kay bawo na tadaan sa answer, no? Kay uniformly distributed naman siya. Okay?
Sige sir. Thank you
So
sir.
kani for example, ang akong i-share ninyo ang kanig kuan at least na amoy idea gamay. Ka share. Kani ato. Yes na. Ni makita ra ninyo ang screen?
Oo. Yes sir.
Yes, so ang atong buhaton na ni is to get the fixed end forces. The fixed end forces is just the equivalent total forces, di ba? So, sa kani, parehas sa itong ibuhat gani ha, di ba? So, mag-pass ka diha o imaginary cutting plane. Okay, so ana siya, may mo reference point, exactly the same, x na siya, di ba? No? So, yung ana na may tabo karon kana. So, pila man ni karon? So, mao man ni karon ang atong R1, di ba, no? Karon mo ni akong force nako no sa kaning imaginary line. How about this one? So may karon x man no? So kx, di ba? So ang kani dire actually kung ang imong kuan actually kx gini siya no. So kani siya is k times of x nimo is l, kl na siya, di ba? So karon og x na siya, so it should be kx. So kani siya is kx. No? Okay. So, walang yapon, displacement nimo 0, di ba? No? Okay, so p x, no? So, ang imong i-sum up man nimo siya. So, mo nang gamit kag differential displacements nimo, no? Okay, so then imo ni siyang i-sum up nimo tanan, no? From 0 to L. Okay, so kani siya is constant. So, ipuput 0 na siya. So, it's like, muna na lang siya. 0 to L. Pila mo lang akong px karon? Px. So, this is equal to R1 minus, so kani siya. You have to consider this area, which is equal to 1/2 x times px, no? 1/2 times, excuse uh, 1/2 times kx, di ba? That should be the area ano niya, no? Kani. Okay, so mo ni karon ni ibutang dere, so it should be what sa namin natabo ni karon? This is now 1/2 kx squared, no? So 1/2 kx squared dx. Sorry, R1 pa man na no? Ito na lang, solvo na lang. Para, so this should be R1 minus 1/2 kx squared, no? Yeah, dx. So the result, this is R1 x minus 1/2 kx cubed over 3, di ba? Yeah, this is now from 0 to L. So let's continue here. I'm owning 0 equal to R1 L minus 16, no? 16 K L cube. Are you still with me? From 0 to L, no? Okay. So that means your R1 is equal to, ibutang nimo dito. So may mo ning K L squared 16, no? 16 K L squared. Ano siya? So ang imong R2, well obviously, ikuan lang nimo, which is equal to kani siya is KL man na siya tanan 1/2 L times KL. Okay, minus 16 KL squared, no? So R2 becomes sama siya KL squared 1/2 KL squared minus 16. Doon sa may kuha na karon 1/2 KL squared minus so minus 16. So yun na lang kuha na to, no? 1/2, so this should be 3/6, di ba? So nahog na siya og 2/6. 3/6 man. So 2/6. So 1/3 na siya. 1/3 KL squared, no? Okay. 1/2 KL, 1/2 L times KL. Okay, good. This one is 1/6 yan, no? 1/2 kx cube over 3. So 1/6 yan. Okay. So mo ni karon ang imong fixed end forces. So imong nodal forces is puro siya padung diri, no? Mo ni imong nodal forces, no? So this should be 1/6 EL squared. This should be 1/3 EL squared. Well, if you add this one, so 1/3 of 1/6, it should be 1/2 siya, no? So 1/3 of 1/6 if you add, so it should be sorry, 2/3 siya, no? Kani 1/2 is 3/6 man siya. O 2/6, no? So this should be 2/6. Okay, add is 3/6. Okay, mo ni siya. Mo ni imong nodal forces. I think na may mga answers ani, no? Asa man mga answer ani be? Na may answer ni Sluyo. So, imagine kwanto ha, 1/6 o 1/3. Let's check. Ano ha? 1/6 o 1/3. R1, and this is now your R2. Oh, so yan na kayo, no? Bright ito mo mga calculus. So, the same ang inyong approach pag solve na sad, no? Sa katong mga other mga types of non-nodal forces. Okay, able to follow, guys? At least natay na puan nga example sa non-nodal forces.
Good, sir. Thank you, sir.
Okay, so if you have no more questions, so that ends our discussions. So see you again next week. Next week, we're going to discuss analysis of two-dimensional classes. I think that's chapter 2 or chapter 3. Thank you.
Yeah, thank you, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.